Thank you. I'm pretty excited to see that so many of you show up for a session that promises to be boring. So I'll leave the excitement with me and give you the boring stuff, and we'll see where we get from here. Now, I'm pretty sure you all have these moments in your career or your maybe hopefully daily life where you've made some application and you want to test some stuff, right? You want to try out some new technologies and try everything that you find. There's probably a lot of talks you've seen today and yesterday that you want to try out. So what you do is you build something, you run it, and it combines everything you could find, right? It does facial recognition to find out the mood that you currently have, then scans the entire internet, streams all of the pages and information it can find to see what kind of greeting is best for the mood that you are currently in. And you're trying that, you're putting in some, for the sake of it, some Spring Web Flux just because you can. And then it outputs, yes, right? Hello world, you're so proud and you're really excited and you're ready to get this into production. Well, unfortunately, production is not really a place for excitement, right? Production is a place where everything has to be boring. Otherwise, it's your phone ringing of excitement in the middle of the night, right? When there's fires ready to be extinguished and stuff like that. So this is the boring stuff, right? You need boring stuff to get it running in production and make sure that it stays running in production. Now, if you've seen other talks of me, you know that I love layered architecture. And recently I came across a slightly different name for it, and I thought I liked the absurdity of the name. It's the Universal BBC Architecture, and it has nothing to do with the broadcasting organization in the UK, I hope. And it's basically box, cylinder, right? The cylinder stores stuff, and there's some boxes in front of it because we want to separate concerns, right? So we do not want to put it in one box, we put it in two because that helps us build better software, I guess. Unfortunately, it doesn't. And the software we build ends up in the infamous big ball of mud, which is obviously not mud. Now, of course, nowadays, you can't come up with one big ball of mud. So what we do nowadays, we have a new style of architecture, which is microservices. We microservice all the things. So we have our little BBCs, and we make them a bit smaller, and we try to deploy lots of them. What could possibly go wrong? And our little BBC boxes are now connected, and we separate some more concerns, in my experience, seemingly randomly. But all these concerns, they are split all over, and that's fantastic. Now, the problem is, if you take the design principles that deliver you a big ball of mud, and then increase the number of deployment units of that design principle, you get a big, messy, let's call it just shit, right? Let's call it what it is. Let's not be. So what we need to do instead is focus on increasing modularity first. Now, there's been some talks about modularity or moduliths. There have been some talks before, so this is not a new topic, right? This is something that we should really focus on. So first, we try to build something that is nicely structured, obviously not a big ball of mud. And as soon as we've proven to ourselves that we can do that, then we can increase the number of deployment units and go there, which is the nice, colorful land of microservices where we all want to be. This is where promises are delivered, right? Not the bottom one. Unfortunately, there are some dark forces of evil in our projects that force us down back into the big pile in the corner. And these are typically technical debt caused by generally managers saying, I want all of this stuff by tomorrow, and can't you just work faster, just think harder, be smarter? I don't know, just try something. But I need it by tomorrow. Those are all kinds of forces that take you down into that. And we need to fight those forces, right? We need every tool in our toolbox that we can get to help us stay up there. Now, I'm a very firm believer of the microservices journey. And that journey always starts with an idea, right? You have a concept, you want to build something. It might be an existing application, that's fine. In that case, you're probably lucky, because you know more or less what you want to build. And you envision generally some, well, microservices, right? You can see the services already. But that journey over there is pretty dangerous, right? There's a dangerous land in between, and you're very likely to get lost and get stuck in that distributed ball of mud thing. So the journey should be, go to this structured monolith first, prove to yourself that you can build the application, then you can split out some of the components or build new components separate of that, slowly and steadily, and then move on forwards. And maybe then you can really go to this promised land of serverless. Hopefully by then it's pretty well constructed and less beta than it is right now. Now, to be able to achieve that, there's this concept that we love at Axonic called location transparency. And it's the principle that components within our application are completely unaware of the location of the other components that it communicates with. Right? Because in that case, we do not need to change any of the logic that we have if we were to take one of these components, split it out of the monolith. Obviously, there's some technical glue that you need to do, right? There's some configuration probably that you need to do to make sure that the communication can actually take place. Right? Communication within a single JVM is pretty simple. We all know that. It tends to get infinitely harder when you have to cross JVM boundaries. So messaging is a very important concept in microservices, right? And we all know of events, right? Events are, in general, interpreted as a notification that something relevant happened, right? In general, they have past tense, and they just describe a fact. There's no way you can deny that fact. It happened, and you better deal with it. And they follow a typical pub/sub kind of pattern. But they're not the only type of message that there is between microservices. And it doesn't really matter how you implement them. Conceptually, you'll also have commands and queries. You'll also have messages that are an indication of one component to another that I expect you to do something. I expect the state of the system to have changed after you've executed this command, as opposed to what it is now. And then there's the other one, there's the query, and the query is, I have a need for information, and I know another component has the information I need. Right? So be very careful that an event and a message are not the same thing, right? A message is the, let's say, parent stereotype of all the types of messages, the commands, the events, and the queries that you can have. Now, these three messages follow different routing patterns, right? A command goes to a single destination. There's a side effect that is caused by that command, and you probably want to get some notification, some OK or not OK back to let you know whether your intent has been followed up upon. Is that even English? Not sure. The queries, on the other hand, they are sent somewhere, and then the sender is probably waiting. Hopefully there's no thread waiting, but at least conceptually it's waiting for a response. It needs information, so it waits for that information to become available before it can move on. And there's some interesting things you can do with queries. You can do scatter-gather. You can send a query to many components, gather all the answers, do some reduction function on it, and take the answer that you like most. Right? For example, I want to get the price of products. You get all sorts of prices. And given that I'm Dutch, my natural reduction function is to take the cheapest one. Right? And that's the price that the product takes. So let's go to a little demo. And I'm not going to live code the whole thing, because that would not be excitingly boring. That would just be plain stupidly boring. So what I did is I did prepare all the code for it, and I'm going to boringly git reset my way through the code and then walk through it. So this is an application. It's going to be available on GitHub as well, so you can check it out literally later on. And there's a couple of classes in here. The API class is the main one. There's a number of commands. Let's move to. There's a couple of commands defined here. So there's the register bike command. It's a bike rental application. Of course, since I'm Dutch, we do everything by bike. We own one normally, so we don't need to rent, but hey, who cares? I register a bike, then I can rent that bike, and I can return it. Right? There's a bike itself, which in this case is an aggregate. This is an Axon concept, which is a consistency boundary of, in this case, only one entity, but in general, a number of entities together. I've also marked it with @entity to indicate this is a JPA entity. And that is a notification also for Axon to say, well, I want to just store this aggregate as a JPA entity, just in a database somewhere. And it has a number of properties. It has an ID, a location, and whoever rented the bike. Could be null if it's not rented at the moment. There's a bunch of command handlers on it. So I can register the bike. That's a constructor, so it creates a new bike. And then if I have a bike, I can rent it or return it. And it checks whether it has already been rented out or not to make sure that the logic works. Then we have a query service that says I have a query handler. I can send a query. Like if somebody wants to know, give me all the bikes, then I will do a find all, and this just delegates everything to a Spring Data JPA repository. Doesn't get any more boring than that. I can do find one. Well, the application is empty. The repository is empty. And then we have a controller just to make sure that we can interact with this application. But the controller doesn't really invoke any of the components directly. So the difference here is that this component says, I want to send a command. So when I do a put on a bike ID, I do a command gateway.send register a bike with that ID and that location. This is fairly trivial to the point where it's useless to do messaging like this, but we can do some cooler stuff on the way, so don't give up just yet. So I could run this application. You'll just have to trust me that it will work. Well, don't trust me, so let's run it. I love that compilation. Compilation is a lot slower on stage than it is in preparation. All right, so I can take my HTTP requests right here, and I can create a back. Let's put it in Barcelona. Run it. There you go. It says 1, 2, 3, 4. It returns the identifier of the bike that we just created. That's great. Now we can rent it out, right? So we can rent it. Let's say I pick it up. OK, bike rented to Allard. Fantastic. Let's try to rent it by Steven. It's my colleague. Ha, too late. I got the bike already. So let me return it to, let's go for a ride. Right, I return in Amsterdam. Well, now Steven is interested in getting the bike. Not sure how he's getting to Amsterdam, that's his problem. So the bike is rented. Nothing really special, and we can execute a query. You can say, what bikes do you have? Well, great, there's one bike that was in Amsterdam. It was rented now by Steven. Right? There's nothing really exciting about this stuff. Oops. Where's my, there it is. All right, so that explicit messaging just gives us the promise of, I don't know, location transparency, but it's not really that valuable. Now, those who know Axon, or those who don't, Axon is a framework that helps you build, let's say, large scale or small scale, doesn't really matter that much, but applications using the principles of domain-driven design, CQRS and event sourcing. Now, CQRS is, who's not familiar with CQRS? Let's do a quick check. Those are very few. That's good. So CQRS is a very simple principle where you say, I take an application and I split the responsibility of that application into two parts. One part is responsible for handling commands, changes to my application, and another part is responsible for handling queries, which is to provide information about the current state of the application. Right? Actually, there's a level of CQRS in any application that you have out there. Right? If you use a search engine, that is a query model. You're doing that to handle queries, right? That is a model designed to handle specific types of queries, right? Typically rich text searches, but there's also other types of queries that you can do with them. So each of those areas will have a different model, right? A model that is focused on doing that part that it's responsible for. So the command model is responsible for validating incoming requests and deciding what to do, whereas the projections are responsible for handling queries and providing information as efficiently as possible. And the reason you want to, and we use events generally to make sure that when we execute a command, we emit events to let the projections update themselves. The reason why we would want to do that is generally because the non-functionals are quite different on any part of the system. Like the purple part on the left might be something that's really complex, right? It's a very complex part of the system, and it's deployed very often. Not a very nice combination to have, so you want to definitely isolate that from the rest. There's some other examples, and the one on the right might be a component that is pretty unstable, and it uses massive amounts of memory for whatever reason. You probably want to be able to separate that out as well, so that if that crashes, it doesn't take down everything else. Of course, try to fix the stability issues, but that's, I guess, obvious. Now, in the example I had earlier, that is a absolutely trivial example, right? It's the simplest application I could think of that shows CQRS. And even in that application already, we see some accidental complexity. So imagine 5 minutes of work, and you have your first accidental complexity case, right? Imagine what happens if you continue working on that for days on end. And the problem is in the bike class. If we look at the bike, the way it's structured, this is very nice information for a view, right? This is the information we want when we do a query. We want to know where a bike is and who has rented it at the moment, right? But to execute commands, to validate whether that bike is rentable at the moment or not, there's way too much information, right? So that information is useful for queries, but not for executing commands. So what we can do is we can apply CQRS to the application that we've just built. And what we need to do for that is git reset. You can do that in your own project, of course, not. There we go. Yes, I'm cheating, I know. I do promise that I did write all of the code that's in here. So what we do, we split the command and the query. So there's different packages now, right? There's a command package. Hey, there's our bike again. What does it look like now? Hey, it's slightly different. It's still an entity. It's an aggregate. But now there's just a Boolean. The Boolean is the simplest form of data, right? It's the atom of our data. Everything else is just a bunch of Booleans in a row. In our API, we added a few events. Because right now, as part of our commands, we start to emit events. And because this is a very simple application, a command results in a happened event, but in more production-like systems, more valuable systems, those commands and events tend to diverge somewhat. And we have some query models, and this one gives us the status of a bike. And here's the data that we had earlier, the bike ID, the location, and the renter. And this is now also an entity. And we have our projection class, and that does some interesting things. Let me try to get some more space. So what this does is it uses a Spring Data JPA repository, which is a pretty boring thing. It just works. It gives you all the stuff you probably need. And it reacts to events, and it says, when a bike is registered, I want to register a new item of status. When I get a bike rented, I'm going to find the bike that was rented and put the renter in there. Right? This just does the simple updates. And then there's some query handlers that say, well, if you want all of them, we do a repository.findAll. Right? The logic is pretty much the same, but we've split the two models. There's now a command model focused on validating whether you're allowed to rent that bike, and there's a query model to tell you where the bike is or who currently owns it. That's all great. But there's so much more, so let's move on. Oh, do you want me to run the application? I'm not sure what you said, but I'll just interpret it as a yes. The other one was still running, so. Now, if you expect any other behavior, I really have to disappoint you because we haven't changed any behavior. Now, the thing is, because of auto-configuration here, with all the infrastructure that we need to get the commands to their destination, the events to publish to their destinations, and even the queries to their destinations, there's nothing in our application that has that type of infrastructure, right? The infrastructure is all auto-configured and auto-wired for us based on, based on the availability of certain other dependencies, right? I mean, in the end, Spring Boot is mostly XML programming, right? It's a bit back to the, Spring 1 days, where you just did a lot of XML and then it worked. It's the same with Spring Boot, but then you do it in the POM. Here we go. We issue a bike. We're not interested in parse. So I'm using an in-memory database for these demos. So I issued my bike. I'm renting it. Fantastic. Stephen wants to rent it. Hooray, it doesn't work. Right. So nothing really changed. It's just the same application again. Let's try to stop it. All right. So we changed a lot of code and nothing really happened, right? Nothing really changed. Okay, great. We've got the Hello World sample, right? There's a lot of exciting stuff happening, but we can't see that from the outside just yet. Because now we're publishing events. And there's something special about events that commands and queries don't have, is that they remain valuable over time. They describe a fact that occurred, and it might be valuable to remember that that fact occurred a couple of days, months, maybe even years from now. Right? But there's also some challenges. How can we guarantee that the publication of that event and the storage of our entity, new entity state, is in atomic operation? How can we guarantee that we had to roll back the database transaction for some reason and did get the event published? There's some solutions for that, yes. But there's another thing about events, is how can you guarantee that the events you emit is a truthful representation of what happened in the past? Basically what we want is the truth, the whole truth, and nothing but the truth. And if events are a side effect of what you're doing, you cannot guarantee this. Right? The events need to be the source of everything. Right? And if something happens, it's in the source, and if it didn't happen, it's not. That's the things we want. So with event sourcing, we don't store the state, as an example on the left. We don't store the fact that currently that order has been returned, as you can see in the bottom, and it has one item of a luxury chair. But with event sourcing, you get the entire history. You get it was created, 2 items were added, 1 item was removed, an order was confirmed, and it was shipped, then it was canceled, and that's why we had to wait for the return shipment, because somebody canceled it after it was shipped. And then we got the shipment. Now, there's some information in there that we have lost on the left. Right? And of course, we can generate that as a side effect, that information somewhere, in logs, for example. But it's very hard to guarantee that those logs are absolutely correct. So in the case of event sourcing, we don't have the stuff on the left anymore. If you want to know what the current state of an aggregate is, we need to replay its history. So the value of event sourcing is in the fact that you've got an audit trail. You know exactly what happened in your application. It's very powerful to do analytics later on. Right? It also helps to improve the modeling. If you get the hang of event sourcing, you'll find that it's a much more natural way to reason about the logic of an application, especially in the command model. It's a lot simpler to say, well, in this case, I do this validation, and then I decide this happened. That's it. Right? You've got an explicit record of something happening instead of an implicit record where you say, well, the state changes. These changes mean that this happened, right? It all becomes very explicit. And they are very nice to test. You can use given when then style testing with event sourcing, saying, given some events in the past, when I execute a certain command, I expect more events. Or maybe no events. I expect an exception, a validation exception, something like that. But there's one more thing, and that event sourcing gives you the power of not now. And that is a very powerful thing, because we always want everything done, or we are forced to get everything done by some time, right? How nice would it be if we could just say, yes, we can do this, but we don't have to do it now. We can do it when it becomes important. I had a customer a while ago, and he said, we need to make sure we capture all of the data for reporting. Oh, that's interesting. What kind of reports do you want to run? I don't know. Then how am I going to prepare anything for those reports? But I said, don't worry. You can go find out what kind of reports you want. You can come back to me, and I'll do nothing with that information. And he was like, what do you mean? I don't care. I don't care what information you think you'll want, because we capture everything we have to capture. And anything we capture right now, we can create the report for you from the day we launched this product in production. Right? And he didn't believe me. He checked up several times. And then there was finally this moment where they wanted some data dump in some specific format for analytics later on, and we were, of course, able to provide that. So now that we have an application that's emitting events, let's see what it takes to do event sourcing. Yes, I know. This is how you do event sourcing. So let's see what changed. So let's start here. The API, nothing changed, right? The same commands, same events. Well, half is off the screen, but you'll have to trust me on that. The bike status, bike projection, nothing changed. These still rely on the same events. The only real change is in the bike, the structure of how we built the bike. And we still have that Boolean field is available, but you can see there's the @entity annotation is now missing. That is enough to tell Axon, I have the intent to event source this thing. You do not need to store its state anywhere. Right? And it becomes default to use event sourcing. We use an aggregate identifier. We could have stayed on the JPA ID, but we don't need JPA in this class anymore. So when we register a bike, we're going to apply an event, because in this case, there's no validation for registration of a bike, which is maybe not realistic, but let's stick to that as an example. And in here, we just make a decision. OK, we want to handle the rent bike command. We want to rent out a bike. The only thing we need to do is check if it's available. If it's not, we throw an exception. If it is, then we have decided that the bike was rented out. Right? And the apply does two things. It stages this event for publication to other components. Right? Note the stages. It's not there yet. It's ready to go out. And it also invokes the methods below, which are the event sourcing handlers. And this is a very important concept in event sourcing, and it has nothing to do with Axon conceptually. If you use event sourcing, you have to be able to reconstruct the bike state, in this case, based off of its historical events. Right? No validation, the things happened. You do not validate anything that happened in the past. You can dislike it, but that does not mean you do not have to act on it. So if a bike was registered, great, then we set the bike ID to bike ID, and we set the fact that it's available. Right? If a bike was registered, it becomes available for rent. If the bike was returned, it's available, and if a bike was rented, it's not available. This is the only thing we care about. There might be hundreds of other events. We don't care about them in this specific aggregate. So the apply not only stages this event for publication, it will also ensure that method is invoked, and it's invoked directly. So on the line of code after apply, you have the state changes that are described in the apply method. Right? So there's no async difficult programming involved. Now there's also one thing that I changed, which is kind of hidden. There's some dependencies here. There's an Axon Spring Boot starter. In the other examples, I just excluded the Axon server connector. There's a new component that we have since late last year called Axon Server. It's like Axon. There's an open source version of that you can just get. There's a Docker container for it, which I'm running here in the demo as well. And in this case, I did not exclude the connector anymore, so that the auto-configuration of Spring Boot will connect the application to Axon Server running on the local host. Because from now on, I don't want to lose the state of my application anymore. So let's start this. Great, it's probably running. And that's the downside of reset. You have to make your changes. Where do we put it this time? Madrid. Whoops. Why not? There we go. We issued a bike now. And of course, the behavior is not any different. I can still rent this bike, and it's bike rented. Right? Nothing in the behavior changed. It's just the way we execute the behavior, and there's still some validation here. And let's return it in, where are we returning the bike? Oh, okay. We're cycling to Barcelona, why not? And then Steven takes it in Barcelona. Great. So now we've got some events. And every time I execute a command, my application loads all of these events, regenerates the bike to check whether the new command is valid, right? So we can go to this page. This is the Axon server dashboard, and we can see that there's one application running. It's connected to this server, and there we go. We can search for the events, and here we see that there's 4 events that have happened. Some very nice XML structure. We'll ignore that for now. But we can see some stuff happened to this specific bike 1, 2, 3, 4 in the past. All right, so now we've got event sourcing going. We can do some more exciting stuff. So again, there's not much infrastructure code that I had to do. It's just because I want to do event sourcing, I just need to restructure my bike aggregates, and the rest of the application just works the same way as everything. Everything is auto-wired. There's no exciting configuration that we need to do. Now, one of the advantages, so I told you about the power of not now, right? So that has to do with the fact that you have the events that are stored, and as new events are stored, you have this event handler reacting to it, right? So I can query the bike status, and it will give me an updated status of the bikes. So every time there's an event, we just update it. But what we can do now is we can create a new event handler. We can create a new projection if we want, and have that start at day 0 and then move its way forward. And hopefully one day it will catch up. So let's do that. Let's implement a new projection. And yes, I'm going to do it that way again. And I'll just run you through the code that has changed. So right now, we just created a new package, history, and there's a new projection. And it's pretty similar, but there's still that information. There's still the bike ID. There's a description of what happened, and there's a timestamp on when it happened, right? Now, we didn't record a timestamp on our events, so let's hope that works out. And then we have our projection that just handles all of these events, right? It's a Spring component. There's some event handlers that says, oh, if the bike was registered, and we can put a timestamp, because we're interested in knowing when actually this happened, right? So great. We can launch this application. Let's stop this one. And now, because the there's still Axon server running in the background. We still have these events, right? So now the application is starting, and it will have this historical information still in there. So this component is going to chase the head of the stream right away. So what we can do is in the requests, we have a history call for bike 1234. And we can see exactly what happened. So this is the new model that we have created. And yes, it's slightly boring in this case, but I promised you boring. We can see that bike 1234 was registered in Madrid on, oh, that was a few minutes ago. Well, and then was rented out, and then it was returned in Barcelona, and then Steven rented it, right? So we can create a new model and not worry about anything we need to replay. This is just by itself. This is just, by doing nothing, you get a replay for free. All right, let's go quickly to the last entry. So now we have this really exciting, quote-unquote, system where we've got commands and events and queries going around, where there's all these messages floating, and everything is nice and streaming. And then we have this stupid HTTP calls to get that information, like polling information, right? Wouldn't it be nice to say, well, let's stream this stuff all the way to the front end, right? I mean, we have Spring Web Flux nowadays, so why not use that to make it streaming? Now, there's a few ways to go about, and my initial naive reaction when we started streaming stuff to the UI was to say, well, we've got an event handler that receives an event. Why not just stream that event all the way to the user interface and let that update itself? And there's a bit of a problem there, because the event handler is probably updating some information, and it has logic on how to update the information based on the event. Now, we would have to duplicate that logic in the user interface. It is very likely that the user interface is written in another programming language than your backend. Since we are at the Spring conference, this is not the Node.js I/O, right? So, since that event handler is already updating information, it has this bike ID location renter properties, and it's updating the fact that Steven was now the renter in Barcelona. So why not stream that message that we are using in the queries anyway, that structure, why not send that as an update? And there's a concept in Axon called subscription queries. You can query for something, say, give me or keep me up to date on the bike 1234. So let's do that. Let's see what we need to do to get that working. So the biggest difference is right now in our projection, in the bike history projection, we want to subscribe to the history of a bike, right? So if something happens to that bike, we want to be notified immediately. So we have an update emitter that we auto-wire that into our projection, and then we say when a bike is rented, we emit. If somebody is interested in the location history, we emit this event, and we say if the bike ID equals the payload of the message, what's this? M is. Sorry. Great, I'm lost. So are you. Fantastic. Basically, we're emitting, and we're saying if somebody is interested in the bike ID that the current event represents, then we're going to send them the update. The M, by the way, is the query, and the payload of the query is the bike ID in our case. And if we look on the other side, we have our controller, and we added a method called history watch. We can watch a bike ID, and it says you do a subscription query, you get a response. And on that response, you can say, I want the initial result, and that initial result is a mono. And it contains a list, or at least an iterable, of the initial bikes or the initial history that we have on this bike. And we want to turn that into a flux. so that we can concatenate that flux with any updates that we get. And we just return that flux. We just return a flux of bike history elements, and we say this produces an event stream, right? So what we can do, whoops, we need to start the application, running out of time here. Yes, so now we get information, and it's still wiggling around there, so we need to get 1, 2, 3, 4 back somewhere quickly. Let's go to our HTTP requests and find return, return, return. Let's return it to Barcelona. Okay, bike return in Barcelona. Let's go back. Yes, return in Barcelona. So it's just streaming this information live to this front end. So that's fairly simple so far. Now we've got about 8 minutes left, and that is plenty of time to take our big ball of monolithic thing to microservices. Because in our journey, I've spent almost all of our time getting there. So please stick around, because we're going to finish the entire journey. Fortunately, doing that is not extremely complex. So conceptually, what we have right now is a monolith, and there's Axon framework handling all the messaging between these components. And what we need to do is scale that out. I did that last year here on this stage, to be actually. And last year, I did that with an event store based on MySQL and Netflix, Spring Cloud Netflix for discovery, and we used RabbitMQ. And trust me, that was not boring. That was, from my perspective, pretty exciting, because I had 2 minutes left to get stuff fixed. That is not the kind of thing we want in production. So what I'm going to do now instead is, and this is something we didn't have last year, to use Axon Server in its place, so we can just distribute that. Now, this is actually a very simple change, because the only thing we are doing is using Spring profiles. I'm not actually separating the logic into different components, but you're all Spring experts, so you'll have to trust me that if I put @profile command, that this bean will only be considered when the command profile is active. Right? There's another, these classes have the history profile on them, right? History profile, and we have the query profile on those. And now what we can do, I have to get out of presentation mode, otherwise I can't find my run configuration. I'm going to start all of these components. So I'm going to start the command part, the query part, and the UI part as separate applications. It's going to start 3 applications, as you can see in the bottom, and they all have different responsibilities, right? So this is a genuinely distributed system on the local host. But at least there's inter-process communication going on. So let's see what happens. Should be able to do that subscription query again, if everything starts. Well, this is what you get. Fantastic. This is what I love about demos. This is the exciting part of where it should be boring. So something happened, and I do not know what. I would love to say it worked on my machine, but this is also my machine, so it should just work. All right, let's try again. Let's try something simpler. Let's do an HTTP request. Yep. So I've also got a generate. So it just says generate. Well, 20 is a bit bit much. Let's generate 2 bikes that are rented out 3 times each. Does that work? Hopefully it does. No exceptions. No exceptions, great. And now we should be able to see the bikes. Yes. So we've still got messaging going on. There's now that 1 bike that we created earlier, and there's the 2 bikes I just generated. And let's move on quickly, because there's one more thing, one really, really boring, and I promise this is the most boring of everything that we want to do. So now we've got this distributed system, right? There's components communicating. And imagine we're going to scale this. There's going to be more components, as we promised we would have, going on this journey to microservices. And then there's going to be more instances of these components, and they're going to be everywhere, right? We've got requests coming in. They send commands to some components. They send events to other components that react by sending queries to other components that then send commands yet to other components that send queries, and we get this really nice things causes things causes things. We need to get some information out of this mess, right? We need to find a way to get an overview of how this. We need to trace the calls, right? So how do we do that? Well, tracing, right? So let's implement that. And I could have done this by hand, but given there's only 2:50 on the clock, I'm going to cheat again. But I promise that I have only changed. What did I change? Here. Only changed this. I added 2 dependencies. Now, if you don't trust me that Spring Boot is XML programming, I think this is proof. So I've got Jaeger running in a Docker container on the background, and right now I can restart my applications using this tracing. Oops, that's not what I wanted to do. I will restart all my applications. Now, if you imagine the things you would need to do to get tracing working properly is setting all sorts of headers in requests and making sure that these headers are passed along and then interpreted on the other side. You need to report spans, you need to start and stop them. So there's a lot of stuff going on, but we don't care. No, I do not want you. Please go away. I love it when you do demos. All right, so let's generate some stuff. Again, and make sure that some traces are created. All right, so we can go to localhost. Oops. So Jaeger UI. Ah, there's a generate data operation. And there it is. Well, 1,261 spans. I think I overdid it a bit. But here's a nice trace. Do you have traces like that in production? I hope not. But what you can see here, there's a bunch of parallel instructions, and that's because I did not change the setting after doing my git reset. So it generated 20 bikes with 10 rentals each, and every rental happens after the previous one, but it's all caused by this one API call that I did. So now you get full tracing of all the commands. You can see that the query component handled the events that came out of it, and you've got everything. And everything is just boringly auto-configured for you. So that was the tracing. And with 10 minutes on the clock, I would say, please try it for yourself. You can check out the code on that GitHub repository. You can cheat your way through like I did, just git reset your way through. And if you have any questions, I will take them after the presentation. Thank you.